Hi everyone, we're going to talk polynomials today. We're going to start with some vocabulary because that is really important for understanding what's going on. So we're going to start vocab part 1. So what is a variable? A variable is a letter whose value is an unknown real number. So it's something that's standing in for a number. We don't know what the number is yet. So it could be A, or it could be C, or it could be B, or W. Whatever letter you want to use is just fine. Algebra is the branch of mathematics that uses symbols to represent unknown numbers or quantities. Okay, a term. A term is a number, so it could be 14, for example, or it is the product of a number and a variable, or variables. So it could be 12x, or it could be like 14ab, and it can raise to a positive whole number exponent. So it could be 23x squared. Okay, those are all terms. A coefficient is the numerical factor. It's the number part of the term. So 14 or 12 or 14 or 23, that is the coefficient, okay? So let's do some examples over here. If the term is 2m, the coefficient is 2. And remember, 2m means 2 times m. Okay, a number beside a letter means multiply. If I have something written like this, where it's negative x cubed over 4, I can write that as negative 1 over 4 times x cubed, and then it's easy to see that my coefficient is negative 1/4. If the term is negative 2b, the coefficient is negative 2. With negative w, the coefficient is negative 1. It's got one of those invisible ones there that we don't write. This really means negative 1 times w. But the coefficient is negative 1. And for this one, the coefficient is just 1. All right? We don't write it, but it's there. And b is the same thing as, it's not negative. B is the same thing as 1b. Okay? We just don't, mathematicians are lazy. We don't bother writing the 1 if we don't need to. But it is there. Okay? Okay, a monomial has a really specific definition, and I'm not going to try and trip you up on this. I just need to give you the formal definition. A monomial is an expression of the type ax to the n, where a is a real number constant and n is a non-negative integer. And then x can be any variable. Okay, so examples of monomials are, where's my pen? 7. Okay, and in this case, 7, which equals 7 times x to the 0, right? Because x to the 0 is 1, so that 7 times 1 is just 7, but we don't bother writing out all that other stuff. We don't need it. 3p to the 5, okay? This is a real number. This is a variable to an exponent that is non-negative integer, okay? 7x squared y cubed. Okay, so that's got a couple of variables with exponents, but they're non-negative integers. They're positive numbers. Okay, or 0, right? Examples of non-monomials. The square root of x does not have an exponent of a positive number or a 0. X to the minus 3. We're not doing much with negative exponents this year, just they exist, but if it has it, it's not a monomial, okay? Or something like 4x to the 1/4 because this exponent is positive, but it's not an integer, okay? Or it's non-negative, but it's not an integer. So those are non-monomials, okay? So we'll do some practice on the next page identifying monomials, but after that, it doesn't become important, except that all of the things that we're working on now are going to be done with monomials, and they don't work with non-monomials, okay? The degree of a monomial is the sum of the exponents on the variables in that monomial, okay? So examples. The variable in this monomial is m, and the exponent on the variable is 2, so the degree of this monomial is 2. For c, there is an exponent of 1 there, right? Because c to the 1 just equals c. We just don't usually write the 1 there, but there is a 1 there, so the degree of that term or that monomial is 1. For this one, 25x squared y to the 5 z to the 4, the degree of the monomial is the sum of 2 plus 5 plus 4, which is 11, okay? We're just adding up the exponents on those ones, okay? On this one, you can imagine that there's an n to the 0 here, right? Because that wouldn't change anything. So the degree of this one is 0, because n to the 0 is just 1. So it's there, could be there, we wouldn't know, but it wouldn't change anything. So the degree of just a constant number, just a number, is 0. And this one is here. Can you see that these two are actually equivalent? This one is just written as 5 squared, and this one is written as 25. So it wouldn't make sense that the degree of this one would be 11 and the degree of this one would be 13. That wouldn't make sense, would it? So we don't care about the exponent on the 5. We only care about the exponents on the variables. So this one is also 2 plus 5 plus 4, which equals 11. So the degree of that one is 11. Okay, so remember, this is worth writing down. Remember, we only care about exponents on variables. Okay? All right, and then just to note that when a term has more than one variable, we usually write them in alphabetical order. So for here, I wouldn't write this as 25y to the 5, z to the 4, x squared. I would put them in alphabetical order. That just helps us when we're trying to find things. Okay, so we recognize that things are the same. So we write them, that's just a convention that we write them that way. Okay, let's do this first example on this page. The coefficient on this one is 4. Is it a monomial? Yes, because the exponent on the variable is a non-negative integer. I only have to say why it's not, if it's not a monomial. And the degree of the monomial is 2, because the exponent here is 2. Okay, so I'm going to suggest you just pause the video here and do this page of practice, and then come back. It'll be much easier if you do this practice first and have more of a handle of what a monomial is, okay? Okay, let's do part 2, vocabulary part 2. So we talked about monomials, and now we're going to talk about polynomials. And poly, of course, means many. So a polynomial is either a single monomial or a series of monomials connected by addition. All right, so for example, 27 is a monomial. It's also a polynomial. Okay, or I could have 2x plus 3 because my 2x is a monomial and my 3 is a monomial, and those are connected by addition. Now, here's another one. 7x squared minus 3x plus y minus 2. So wait, Ms. Oaks, you said You said they had to be connected by addition. Well, yes. So let's just write this differently. I could write this as 7x squared plus negative 3x plus y plus negative 2. And now I have, here's a monomial, here's a monomial, here's a monomial, here's a monomial, and they're all connected by addition. All right, but mathematicians are lazy, so we don't usually write it that way. We normally write it this way, but it still meets the definition of a polynomial. Okay. All right, a monomial is a polynomial with one term. That makes sense. Mono is mono, means one. Example 14 or 2m, those are both monomials. A binomial is a polynomial with two terms. Bicycle, I can think of all kinds of, bifurcate is the word that came to mind, but that's like a biology thing where something splits in two. So the word bi means two. So examples of binomials, 5m plus 2 or x squared minus 4. Those have two terms each. A trinomial, I'll bet you can guess that that's a polynomial with three terms. Think tricycle or tripod. So 4x squared minus 2x minus 4 is a trinomial, or 3m cubed minus m squared plus 7. That is also a trinomial, all right? So notice that all of these polynomials, the ones that I've done, the binomial and the trinomials, I have listed them in each monomial within it in each term is done in order of decreasing degree. So this term has a degree of 2, this term has a degree of 1, and this term has a degree of 0. So I've done them in decreasing order. This one has a degree of 3. This has a degree of 2. This has a degree of 0. So I've done them in order of decreasing degree. Okay, and that is it's an important convention because it makes things look similar. Okay, it makes it look the same from one thing to the next, so you can see what you can do with it if you can see the shape that it is, which is easier to do if you've done it in decreasing order. Okay, the leading term of a polynomial is the term of highest degree. So, for example, I'm going to write out a polynomial, 5x cubed y squared plus 7x squared y minus 2x to the 5 y cubed. Okay, so this first term, there's a 3 and a 2, so this has degree, let's write this, degree. Cool. So the degree of this is 5. 7x squared y, there's a 1 here, so the degree of this term is 3. And this one has a degree of 8. That makes this the leading term. And we would normally write that polynomial as negative 2x to the 5 y cubed plus 5x cubed y squared plus 7x squared y. Okay, because we do normally write it with the leading term first. I just wanted you to see one where the leading term was not first so that you don't think that it's the first one in the list, because it's not always. You have to check for it. Okay? Okay, the degree of a polynomial is the degree of the highest degree term in the polynomial. So in the example above, the degrees of each term, there's one with the degree 5, there's one with degree 3, and one with degree 8. So this whole trinomial has degree 8. Okay? There's a difference between simple and easy. This is pretty simple. Like, there's really clear definitions of what you need to do. Is it easy? Yeah, not so much. Okay, this takes some practice because there's a lot of words that have been thrown at you and we have degrees all over the place. And what we need to do is do some practice. So let's do a little bit of practice here. I'll do the first one. This is a polynomial. It has two terms, a and a squared, because they're connected by the addition. Classification means, is it a monomial, trinomial, binomial? Okay, so this is a binomial. Okay, and if we had one that had 4 or more terms, we would just call it a polynomial. It doesn't have a specific name. Okay, the leading term of this one would be the a squared, because this one has got degree. This has got degree 1 and this has got degree 2. So my degree 2 is going to be my leading term, and the degree of the polynomial is the higher of these two numbers. Okay, it is a little confusing because when you're looking for the degree of the monomial or the term, you're adding the exponents on the variables, but when you're looking for the degree of the polynomial itself, you're just picking the highest one. Okay, so there's some practice here for you. I'm going to suggest that you pause the video and do this practice. And I would really recommend that you don't do any more than 2 or 3 before you check the answers, because I'd hate for you to go through all that work and just be getting it wrong. That would be terrible. Okay, so pause the video, go do that, come back. We've got a little bit more to do. Okay, welcome back. Now we are going to look at algebra tiles. We're going to use algebra tiles to model polynomials. I will be giving you in class cardstock that you can cut out to make your own polynomials. So we have manipulatives we usually use in class, but I think with COVID, that's just not going to be a thing. So we'll give you your own and you can cut them out. Okay. So we have 3 shapes. This little square here, it's a square and it's 1 unit by 1 unit. That's how big it is. So 1 times 1 is 1. So this is considered a positive 1 tile. And then if you flip it over, it's white on the other side and it's negative. Okay. Now, some courses, actually, some textbooks have these things flipped. Where the colored one is the negative and the white ones are positive, but that's not how we're going to do it. We're going to do it this way. The colored one, whatever color it is positive, and the white one is negative. Okay? Okay. These rectangular bars are our variables. So this one is, notice that it is the same thickness as the 1 square, but its length is different, and its length is x. So the area of this is x, and this is a positive x tile, okay? Or a y tile or a w tile or whatever letter you need it to be, that's fine, but it's a positive variable. And then the white one, same size and shape, that one's a negative. Okay, and then if we draw a square, it's a bigger square, which is x on this side and x on this side. This is an x squared tile. This is x times x, okay? And then this is a negative x squared tile, okay? So right now, all we're going to do is use algebra tiles to model some polynomials. So we have 2x. That means I have one x tile and another x tile, and they are both colored in because it's positive. Okay, oops. Now, I don't expect these to be perfect, but I do expect them to be reasonable and they shouldn't be oval, okay? And they shouldn't be vastly different in size if they're both supposed to be the same thing, okay? I could also have drawn these this way. Oh, the software does not like me coloring things in. Okay, so that's fine too. That's 2 x tiles. If I have x plus 3, I have a rectangle. See if it likes it better like that. And then 3 1 tiles. Okay. If you draw these as circles, I will make you redo it on a quiz. Okay, because you can make squarish shapes. Okay. All right, this one is going to have a negative x squared, which is a bigger square, and then 4 x's. And my x is whatever size I'm making my x length. All of my x's should be the same size, more or less. Okay, so these are all going to be the same height within my drawing capabilities. Okay. And then, so there's my 4, so there's my negative x squared, there's my 1, 2, 3, 4 x's, and then minus 3, 1, 2, 3. So you need to be able to tell, I need to be able to tell the difference between your 1s and your x squareds, okay? Because they're both the same shape, they have to be very different in size so that I can tell what you're intending, okay? All right, a couple more examples. Now we're looking at algebra tiles and we're saying what expression is represented by them. So I have 2x squared tiles. So I have 2x squared and I have 1 tile. All right. Here I have 1x squared tile and I have 3 negative x tiles. So I write that as negative 3x and then plus 2. And I would normally write that as x squared minus 3x plus 2. But if writing it like this makes more sense to you because that's what you have sitting in front of you, that's okay. Baby steps, we'll get there eventually. Okay, but if you want to write this down for now, that's just fine. Okay. All right, and this one, this is actually the same thing. This is also a single x squared and 3 negative x tiles and 2 positive tiles. I just have them, it's just laid out differently, but they're equivalent. I could just move things around and they'd be the same. Okay. All right, that is the end of this. There is just a few questions of practice for you to do, and then mark it. Hopefully you marked everything else already, and then I guess you can write the quiz. Bye.